OpenAI just released 2 brand new models inside of ChatGPT that are great at reasoning. They're going to be good at math, much better than any model that's ever been released. And they're also good at programming. And in this video, I wanted to show you all the different examples that OpenAI actually published on their website. I pulled them out and I put them in this video so you could watch all of them in the same video. I did also take this on a test drive in a video I just published right before this one. So go ahead and check that out. But this should show you all the different capabilities that are inside of these new models.
It takes a lot of effort to build code that runs consistently and works very well, right? And I think the thing that's really, really exciting now is every human is going to be able to build way more. And there's so much more to build. And that's what gets me really excited. Yeah, I'm Scott Wu. I'm the CEO and co-founder at Cognition. The thing that's interesting about programming is that it's changed in shape like over and over the last 50 years. Programming used to be punch cards, and people used to, that was how it was first done, right? Along the way, there are all these different technologies of the internet and cloud and mobile and so on. I'd say as a whole, it's only gotten easier to produce code and to produce real programs. Being able to write code out line by line is one thing, but also being able to understand and interpret logs, being able to navigate and run commands that actually, affect the real world is a big part of programming. This new model O1 is really able to process and make decisions in a more human-like way. We're getting a glimpse into a new generation of models. We worked closely with OpenAI on iterating on it and giving our feedback and testing it out. What we found was that O1 was just incredible at this kind of reasoning. I guess I should explain what Devin is and stuff from the beginning. Yeah. Okay, cool. Yeah, so, at Cognition AI, we're building Devin, the first fully autonomous software agent. And, what that means is that Devin is able to go and build tasks from scratch and is able to work on problems the same way that a software engineer would. And so here, actually, I asked Devin, to analyze the sentiment of this tweet, to use a few different ML services out there, to run those out of the box and break down this particular piece of text and understand what the sentiment is. And so first, Devin will make a plan of how it plans to approach this problem. Yeah, and so here, it had some trouble fetching it from the browser. And so then instead it decided to go and go through the API and fetch the tweet that way, right? And all of these little decisions, things like that happen all the time. You can really see here how much this human-like reasoning makes a difference. Finally, it's able to get this all the way through. It says the predominant emotion of this tweet is happiness. The soul of programming has always been the ability to take your ideas and turn them into reality. And now you can be able to do that much faster and cleaner than ever before.
The first example I have is very simple. This just counting the letter R's in a word strawberry. So let's start with the traditional, existing model, GPT-4o. So as you can see, the model fails on this. There are 3 R's, but the model says there are only 2 R's. So why does this advanced model like GPT-4o makes such a simple mistake? That's because models like this are built to process the text, not with the characters or words. It's somewhere between, sometimes called a subword. So if we ask the question to a model, a question that involves understanding the notion of characters and words, the model can really just make mistakes because it's not really built for that. So now let's go on to our new model and type in the same problem. This is an O1 preview, which is a reasoning model. So unlike the GPT-4o, it starts thinking about this problem before outputting the answer. And now it outputs the answer. There are 3 R's in the word strawberry. So that's the correct answer. And this example shows that even for seemingly unrelated counting problem, having a reasoning built in can help avoiding the mistakes, because it can maybe look at its own output and review it and just be more careful and so on.
I want to show an example of a coding prompt that O1 Preview is able to do, but previous models might struggle with. And the coding prompt is to write the code for a very simple video game called Squirrel Finder. And the reason O1 Preview is better at doing prompts like this is when it wants to write a piece of code, it thinks before giving the final answer. So it can use the thinking process to plan out the structure of the code, make sure it fits the constraints. So let's try pasting this in. And to give a brief overview of the prompt, the game Squirrel Finder basically has a koala that you can move using the arrow keys. Strawberries spawn every second and they bounce around, and you want to avoid the strawberries. After 3 seconds, a squirrel icon comes up, and you want to find the squirrel to win. And there are a few other instructions, like putting OpenAI in the game screen and displaying instructions before the game starts, etc. So first you can see that the model thought for 21 seconds before giving the final answer. And you can see that during its thinking process, it is gathering details on the game's layout, mapping out the instructions, setting up the screen, etc. And so here's the code that it gave, and I will paste it into a window, and we'll see if it works. So you've seen there's instructions, and let's try to play the game. Oh, the squirrel came very quickly. But, oops, this time I was hit by a strawberry. Let's try again. You can see that the strawberries are appearing, and let's see if I can win by finding the squirrel. Looks like I won.
It's impossible to be an expert in every single gene. There's 20,000 genes. Like, you can't keep everything straight, but AI can. My name is Catherine Brownstein. I'm a geneticist here at Boston Children's Hospital. I'm also scientific director of the Manton Center for Orphan Disease Research. I deal with the N of 1 cases where no one has seen that presentation before. The patients don't know what's going on. They're really medical refugees in some way. It's like wing walking. Like, you're seeing things, and you're seeing genetic things, you're seeing phenotypic things, and you're trying to connect them, and none of it's been seen before, but like, you think you are the only one in the world, but really, sometimes there's a whole community. They just haven't come together yet. When before I would look up an article, and then look up another article, and then look up another article. Chat with reasoning is so much easier to use. It's just a quick prompt to summarize it for me, and then summarize this part for me. I mean, it's just way, way faster. This is a case of excruciating pain in their bladder. We can't figure out why. So I can go here and say, can you tell me about citrate synthase? And it tells me that it is expressed in the bladder, and it could potentially be related to bladder health. So the decreased citrate synthase activity, oh, this is really smart, because I don't know from this variant if it's like knocking down activity or causing too much activity. It's actually really hard to figure that out sometimes. And so it gives both options, so I can think about both ways that it could be going. That's actually really cool. I go down a lot of rabbit holes that do not yield anything useful, and being able to increase the percentage of rabbit hole to useful information is killer. There's a level of obsession that all of us have. I think we also have the cases that keep us up at night where, you know, we really can't figure out why we can't figure it out. No case is ever closed.
So the example I'm going to try out is almost a code cracking of a badly corrupted Korean sentence. So here I pasted in the prompt, and I'm asking the model to translate this badly corrupted Korean sentence to English. And as you can see, this is not a valid Korean sentence. So let's start with the existing model, GPT-4o, and see how it does. The model is just not able to understand this text, which is a valid response because this is not a valid language. So what's happening here? So Korean is an interesting language in that when we form a character, we can combine vowels and consonants, sometimes put the consonant at the bottom, and so on. One way to corrupt this character is to add in some extra unnecessary consonants to it. And that combination is so unnatural to native speakers, so they can just, when they see it, just automatically undo that change and understand the text. So this is character level corruption. We can do that at the phrase level, we can also do that at the sound level, and so on. People have come up with various methods like this, and I found them really interesting, so I adopted a few of them to create this example. So if you understand Korean, this part that I'm highlighting now, you can read it off as a 지구상 어떤 번역기도 읽을 수 없지만 한국인들은, and so on. I'm not going to read off the whole thing, but this is the idea. Koreans can read it, but the models find it so difficult to understand. So now let's go on to our new model, O1 preview, and see if reasoning can help solve this problem. So I typed in the same thing. Unlike GPT-4o, this model starts thinking through this problem before outputting the answer. So it's decoding the garbled text. So that's actually the right approach, because this is, I gave a translation task, but the underlying task is actually decoding this problem. So it started off with the right path, and then I'm examining this text, deciphering the text. Deciphering is actually the right verb to use here, enhancing the translation, and then actually it starts unpacking some part of it. So here, 모음과 자음의 다양한 변환으로, and so on. This is already an decrypted part of this, and then once the model figures it out, that part, everything else is just easy enough. So it does the other sentence too, and so let's close this thought. So it thought for 15 seconds. The final translation the model output is, no translator on earth can do this, but Koreans can easily recognize it. There's a method of encrypting Hangul by inputting various transformations of vowels and consonants. It creates a way to make it look different on the surface. It can even confuse AI models. I think this is a perfect translation of the sentence. So this illustrates how general purpose reasoning models like O1 preview can help seemingly unrelated questions like this, which is almost like a code cracking. So I hope this illustrates how reasoning can be a powerful tool for solving your problems.
I really like this puzzle because it's been a puzzle from a computer game I've been playing as a kid. The riddle reads as, a princess is as old as the prince will be when the princess is twice as old as the prince was when the princess's age was half the sum of their present age. Even if it even reads hard, it's kind of like it takes a while for a human to understand and translate this problem into how to actually solve it. The question is, what is the age of the prince and the princess? And let's ask our reasoning model how it will do with that. And again, we can observe a little bit its thinking process through like decoding the problem, understanding what are the equations that the ages of prince and princess need to fulfill, and let's see for how long the model will need to think about it. Just similarly as humans sometimes think longer and shorter on a problem, our models do the same thing, and after a while, I hope the model will give us a correct answer here. The model is still thinking about it. It's not the easiest problem, but we got the answer just right now. The model also walks us through the solution. In this case, what are the variables, what are the conditions, how to translate this problem into English, and how to solve those equations where they are just real time. Together, we even got a message about verification, and we got the answer where the prince's age is 6 times k for any natural number k, and the princess's age is 8 times k, that natural age, which also is the correct solution for the problem in that game.
I can kind of easily follow the reasoning. I don't need to trust the result. I can just look, what did it do? Who are you? Oh wow, who are you? Very big question. I'm Mario Krenn. I'm a quantum physicist. So quantum physics is the study of the smallest particles. I want to understand how the world works. Here I would ask a question about the application of a certain quantum operator, which I know previous models like GPT-4 would very likely fail in this task. But here, in contrast to answers from GPT-4, this one gives me very detailed mathematics. This is correct. That makes sense. Here I think it tries to do something incredibly difficult. The really interesting thing is, how does the world work? But if you know how the world works, it helps you potentially to build new technologies.
So one of my favorite puzzles that I would do when I was a little kid is called a nonogram, where you're given an empty grid and then some numerical clues that tell you which squares in the grid you have to fill in. And I thought we could have the model play a little game where it first generates a puzzle to solve, then we ask another instance of the model to try to solve the problem that it generated. So yeah, I'll ask it, generate, say, a 5x5 nonogram where the final answer is the letter M. We'll see what it comes up with. All right, we see it just gave us a little puzzle. We'll go ahead and copy this, open up another window of O1, ask it, solve the following puzzle, and let's say, visualize the answer in some pretty way. Why not? This puzzle doesn't look like it's too hard, but the way that a nonogram works is for each row and each column, you're given a list of numbers, and the numbers tell you how many squares are filled in. And if the squares are consecutive, then you'll see like a 2 for 2 consecutive squares. If there's a space between them, you'll see a 1, 1. And so you're supposed to just try to figure out which squares do I indeed have to fill in. And it looks like the model got this right. Illustrated a nice little letter M. But I think one of the things that is like nice about examples like this is it's similar to like Sudoku or a crossword, for example, where you have to kind of make a guess and then see if that's a right guess or a wrong guess, and then backtrack if you get it wrong. And so any type of task where you kind of have to search through a space where you have different pieces pointing in different directions, but there are mutual dependencies. So you might get a bit of information that tells you that these two pieces contradict each other. Like a model like O1 is really good at trying to refine the search space here.
The first of the problem I would like to show is an interesting common sense reasoning thing that all the previous type of large language models didn't do that great, which is about physics and about physical objects and their relationships. The problem reads, assuming the laws of physics on Earth, a small strawberry is put in a normal cup and the cup is placed upside down on a table. Someone then takes the cup and puts it inside the microwave. Where is the strawberry? And explain the reasoning behind it. It's a simple problem. Every human will know straight away what is the answer, but it's something that language models are struggling a little bit, and then we can see how does this model do it. And we can also a little bit have a glimpse on what is happening in the head of the model, and we also get a pretty nice answer of what happened, why it happened in this particular scenario. The model needed to spend a little bit more time thinking about it and analyzing what did actually happen there. It couldn't. The model has a bit of a harder time thinking, especially about scenarios involving physical objects, and then you need a little bit more time thinking for that.
So I want to talk about a prompt that GPT-4 really struggles with, but our new model O1 Preview can do pretty well. And the prompt is simple. It's write a 6-line poem about squirrels playing koalas at soccer that meets the following constraints. In line 2, the last word should end with I. In line 3, the second word begins with U. In line 5, the second to last word is eucalyptus. And in the final line, each word has 2 syllables. So first we'll try with GPT-4o. And we'll see that the answer from GPT-4o meets some of the constraints, but not all of them. The reason it's hard for GPT-4o is it has to get it correct on the first try. It can't check that it meets the constraints and then revise the poem. Now let's try the same poem with O1 Preview. And we'll see that differing from GPT-4o, O1 Preview starts thinking before giving the final answer. And you can view a summary of the thinking process of the model. So first you could see it's starting to think about different words for rhyming. Then you could see it wants to make sure the last word matches I. It thinks about words like alibi. It's analyzing word endings, and it's thinking about words like ski. Then it's piecing together phrases, but it thinks they don't quite fit. It's thinking about phrases where the second word starts with U. Then it's tweaking the words to fit the 2-syllable rule for line 6. It's digging into various 2-syllable word combinations. Then it's checking whether the poem aligns with all the guidelines. It's working through the poem to analyze the soccer aspect. And now let's look at the final poem. So in the second line, the word safari does end with I. In the third line, the second word unleash does begin with U. In the second to last line, eucalyptus, the second to last word is eucalyptus. And finally, in the final line, under moonlight creatures scatter, indeed each word has 2 syllables. So this is an example of a prompt where, because the model can generate candidates and do reasoning before giving the final answer, it's able to give a higher quality response.
Yeah, let's maybe demo a game, right? Can we like implement like a small game on HTML? What game do you like the most?
Let's go old school, Snake.
Oh, nice. Snake is a brilliant choice. Okay, let's try it out, shall we? Let's implement the snake with HTML, JS, CSS. Maybe let's use WASD to control the snake. Let's hit enter. All right, so wow, the model gives us a really long implementation of the snake game. Let's see how it goes.
Can you describe to me what it's doing?
So it basically thinks through like how we design the game, how to design the canvas, how to design the grid, and how to implement the different logic of this snake game. Let's copy the code, and let's HTML, and let's see what's this snake game. Okay, we have a snake game. It says press spacebar to start or restart, use WASD to control. Okay, we have this little green snake, and it tries to eat this red apple, I assume. Okay, let's make it more spicy.
Let's make it harder.
Yeah, let's make it harder. What are the options in your mind?
Can you put in some obstacles?
Oh, that's a brilliant choice, right? The snake game should have some obstacles. Do you have any design choice you want to make in the obstacles?
Maybe make the obstacles the letters AI.
Oh, that's nice. Let's see. Tell this model to add some obstacles, and they should form the letter AI. Right, now the model is thinking, and it returns us a new implementation that tries to further implement AI into the grid. All right, and then after outputting the code, it also gives us some description of what are the changes or the enhancements, and let's see whether the code works. All right, now it actually looks like a giant AI on the screen, and there are all the obstacles. So it's really cool, right?
Very cool. Yeah. It's exciting.
Yeah, it's a very exciting and smart model. And as you see that the model really tries to see or try to think about all the instructions I give to the model and tries to follow instructions and try to correct its own errors.
All right, so the example I'm going to show is writing a code for visualization. So I sometimes teach a class on transformers, which is a technology behind models like ChatGPT. And when you give a sentence to ChatGPT, it has to understand the relationship between the words and so on. So it's a sequence of words, and you just have to model that. And transformers utilize what's called a self-attention to model that. So I always thought, okay, if I can visualize this self-attention mechanism and with some interactive components to it, it will be really great. I just don't have the skills to do that, so let's ask our new model, O1 Preview, to help me out on that. So I just typed in this command and see how the model does. So unlike the previous models like GPT-4o, it will think before outputting an answer. So it started thinking. As it's thinking, let me show you what are some of these requirements. I'm giving a bunch of requirements to think through. So first one is use an example sentence, the quick brown fox. And second one is when hovering over a token, visualize the edges whose thicknesses are proportional to the attention score. And that means just if the two words are more relevant, then have a thicker edges and so on. So the one common failure in most of the existing models is that when you give a lot of the instructions to follow, it can miss one of them. Just like humans can miss one of them if you give too many of them at once. So because this reasoning model can think very slowly and carefully, it can go through each requirement in depth, and that reduces the chance of missing the instruction. So this output code, let me copy paste this into a terminal. So I'm going to use the editor of 2024. So Vim HTML. So I'm just going to paste this thing into that and just save it out. And on the browser, I'll just try to open this up. And you can see that when I hover over this thing, it shows the arrows, and then quick and brown and so on. And when I hover out of it, it goes away. So that's a correctly rendered version of it. And when I click on it, it shows the attention scores as just as I asked for. And maybe there's a little bit of rendering, like it's overlapping, but other than that, it's actually much better than what I could have done. Yeah, so this model did really nicely. I think this can be a really useful tool for me to come up with a bunch of different visualization tools for my new teaching sessions. We're starting a series of new models with the new name O1. And this is to highlight the fact that you might feel different when you use O1 compared to previous models such as GPT-4o. So as others will explain later, O1 is a reasoning model. So it will think more before answering your question. We are releasing two models, O1 Preview, which is to preview what's coming for O1, and O1 Mini, which is a faster, smaller and faster model that is trained with a similar framework as O1. So we hope you like our new naming scheme, O1.
So what is reasoning anyway?
So one way of thinking of reasoning is that there are times where we ask questions and we need answers immediately because they're simple questions. For example, if you ask what's the capital of Italy, you know the answer is Rome, and you don't really have to think about it much. But if you wonder about a complex puzzle, or you want to write a really good business plan, you want to write a novel, you probably want to think about it for a while. And the more you think about it, the better the outcome. So reasoning is the ability of turning thinking time into better outcomes, whatever the task you're doing.
It's been going on for a long time, but I think what's really cool about research is there's that aha moment. There's that particular point in time where something surprising happens and things really click together. Are there any times for you all when you had that aha moment?
There was the first moment when the model was hot off the press. We started talking to the model, and people were like, "Wow, this model is really great," and starting doing something like that. And I think that there was a certain moment in our training process where we trained put more compute in RL than before, and train first of all generating coherent chains of thought. And we saw, wow, this looks like something meaningfully different than before. And I think for me, this is the moment.
I think related to that, so when we think about training a model for reasoning, one thing that immediately jumps to mind is you could have humans write out their thought process and train on that. One aha moment for me was when we saw that if you train the model using RL to generate and hone its own chain of thoughts, it can do even better than having humans write chains of thought for it. And that was an aha moment that you could really scale this and explore models' reasoning that way.
For a lot of the time that I've been here, we've been trying to make the models better at solving math problems, as an example, and we've put a lot of work into this, and we've come up with a lot of different methods, but one thing that I kept, every time I would read these outputs from the models, I'd always be so frustrated that the model just would never seem to question what was wrong or when it was making mistakes or things like that. But one of these early O1 models, when we trained it and we actually started talking to it and started asking it these questions and it was scoring higher on these math tests we were giving it, we could look at how it was reasoning. And you could just see that it started to question itself and have really interesting reflection. And that was a moment for me where I was like, wow, we've uncovered something different. This is going to be something new. And it was just one of these coming together moments that was really powerful.
Thank you, and congrats on releasing this.